right, lesson 4b, exponential function manipulation. So example 5 here says a graph f of x equals 2 to the negative x on the grid at the right. Then use the graph to obtain the graph of g of x equals 2 times raised to the negative 2x. All right, so they gave me a bunch of x's here, so I could use transformations. I know that this is just going to be a reflection across the y-axis. But I could also use just plug and chug here. So I know if it's 2 to the negative x, which is a negative 2, that's just 2 squared, which is 4. 2 to the negative 1 is 2 to the first, which is 2. 2 to the 0, or negative 0, is just 2 to the 0, which is 1. 2 to the negative 1 is 1/2. And 2 to the negative 2 is 1/4. And we also have our horizontal asymptote, which it didn't shift up or down with that transformation, so therefore it's still going to be at y equals 0. And so we can graph that. So x is negative 2, y is 4. And 1/4. All right, g of x, g of x is just going to be, it's still going to have that reflection, which is why it's now decreasing instead of increasing, by the way, on the previous one. But we're also going to do a horizontal compression by the reciprocal of 2, which is 1/2, okay? So when you horizontally compress something, you push it in from the left and from the right, you're going to make it go up steeper. So I expect to see this closer to my y-axis because it's going to be increasing at a faster rate, or decreasing at a faster rate if you read it from left to right. All right, so let's see. We could also just plug in some points too if you needed to. So I'll show you that one. So we have 2 to the negative 2 times negative 2, which is just 2 to the 4th, which is 16. And then we have 2 to the negative 2 times negative 1, which is 2 squared, which is 4. 2 to the negative 2 times 0 is 2 to the 0, which is 1. 2 to the negative 2 times 1 is 2 to the negative 2, which is 1/4. And then 2 to the negative 2 times 2 is 2 to the negative 4, which is 1/16. And again, I still have my horizontal asymptote at y equals 0. Now I can't do the negative 2, it's up at 16, but I can do negative 1, which is going to be up at 4. And I know that when I graph out of that, it's just going to be going up really steep because at negative 2, I should be all the way up at 16. G of x, and the first one I graphed there was h of x. I'm sorry, f of x. All right, example 6 says show that the function g of x equals 2 raised to the negative 2x can be written in the form of h of x equals a times b to the x using the transformation properties in the table shown on the previous page, so last lesson. It says describe the transformation of the y-intercept from the parent function f of x equals 2 to the negative x for g of x and h of x. All right, so we start out with the g of x is equal to 2 raised to the negative 2x, which this is the same thing as saying 2 to the negative 2 to the x, because when they're side by side, those exponents are multiplied, and we know that 2 to the negative 2 is 1/4 to the x. So it's been written in the form of Well, our note says h of x equals a times b to the x. So what number would be right here? There's a 1 if it's not written. So we know that our h of x is just 1 times 1/4 to the x. So we're just going to write it as 1/4 to the x. And so that's the difference, is ours actually had like, our directions were a little bit different in our notes than what is showing on here. So it should in the form of h of x equals a b to the x. Okay. All right, then it said to describe the transformation of the y-intercept from the parent function f of x equals 2 to the negative x for g of x and h of x. So our parent function is actually f of x equals 2 to the x. So let's take that negative out. All right, so for g of x is 2 raised to the negative 2x. So we know that it is a reflection wait a minute, I'm confused by my letters now because it says g of x and h of x, but we only have f of x. And h of x. Nope, we have g of x right here. Okay, there it is. Now I'm good. I'm sorry. All right. So, for g of x, we have the negative and the 2. So we know that for g of x, the negative is a reflection across y-axis. And we know the 2 is a horizontal dilation by 1/2. All right, so because it reflects across the y-axis, that's not going to cause that y-intercept to move. And then a horizontal dilation by 1/2 is going to affect my x values and not my y's, and so 0 times 1/2 doesn't affect it to move. So there will be no change in the y-intercept. Then for h of x, it just gave us a different base is all it did. And so because it gave us a different base, it's still going to give us the same y-intercept. So only a different base. With no transformations. It's a parent function. So the y-intercept is still 0, 1. All right, example 7 says use the grid at the right to graph f of x equals negative 2 to the x and g of x equals negative 2 to the x plus 3. Let's just label the y-intercept for each function. So let's do that. So first let's find our y-intercept. So remember the y-intercept is when x is 0. And be careful here because it's a negative 2 to the 0. The negative is not actually raised to the 0. Otherwise they'd have put it in parentheses. So I have a negative 2 to the 0 is 1. So I know my y-intercept is at 0, negative 1. And then for g of x, PEMDAS says exponents first. I have negative, that's 1, plus 3, so we get 2. So we know it's going to be a 0, positive 2. Alright, and so let's see, what I'm going to do here real quick is I think I'm going to write myself down some ordered pairs just to help me out. So for my parent function is 2 to the x. And so if I pick some values, and I plug them in, 2 to the third is 8, 2 to the 2 is 4, 2 to the 1 is 2, 2 to the 0 is 1. So 2 to the negative 1 is 1 over 2, then 1 over 4, and 1 over 8. And my horizontal asymptote is still at y equals 0. Now, the reason I did that is I can either make new tables for these, or we can just kind of think it through. So we know for f of x, it's negative 2 to the x. And so our y's are just going to change signs. Our y's are multiplied by negative 1. So all of my y's are going to become negative. I'm going to reflect across the the x-axis. And when I reflect, even though it does affect my y's, negative 1 times 0, which the horizontal asymptote was at, it doesn't change it. It's only going to change if it has a vertical shift up or down. Now, if you look at g of x does have that vertical shift. That horizontal asymptote is going to change. And so I'm actually going to do that one first. So I see that my graph, my vertical shift is up 3, so I'm going to take that that horizontal asymptote, and I'm going to move it up 3. Now it's the same graph we just did, but now it's up 3. So I'm going to take each one of those points and just move them up 3. And then B is to describe the transformation for each function compared to the parent function y equals 2 to the x. So for f of x, we said it was a a reflection, It's a reflection across the x-axis. And then for g of x, it has the negative as well, so we know it's a reflection across the x-axis. And then it's got that plus 3, which is a vertical, you can say shift, or we can say translation. Up 3 units. All right, example 8 says the graph f of x equals 1/3 to the x on the grid at the right. Then use the graph to obtain the graph of g of x equals 1/3 to the x minus 4 plus 2. All right, so first let's find the y-intercept. So y-intercept, remember x is 0. So we're going to find g of 0. Now remember that negative exponent that exponent can go to the top and the bottom, or we can say first, because it's negative, let's just go ahead and flip our fraction. So this is going to become 3 over 1, which is the same as 3 to the positive 4 plus 2. 3 to the 4th is 81 plus 2, so our y-intercept is at 83. And describe the transformation for g of x compared to the parent function f of x equals 1/3 x. So what is our transformation here? So let's look. So we have the x minus 4, which means that we're going to have a horizontal translation to the right 4. And then we have the plus 2 at the end, which is a vertical translation. Up 2. And so if you think about the point that was my y-intercept at 0, 1, now if I'm going to go to the right 4, I'm going to add 4 to my x's. So now it's at 4, comma. If I'm going up 2, I'd add 2 to my y's. Which is it? I'm sorry. So 1 plus 2 is 3. So my new point is no longer the y-intercept, but the 0, 1 is now going to be at the point 4, 3. And so we can graph these. So let's see. We've got 1/3 to the x. So this will give me 1/3 squared, which is 1/9. 1/3 to the first, which is 1/3. 1/3 to the 0 is 1. Now here we have 1/3 to the negative 1. Remember, the negative makes a fraction flip, so that's 3 to the 1, which is 3. And then we have 1/3 to the negative 2, which is the same as 3 to the positive 2, which is 9. And again, we didn't shift up or down any, so our horizontal asymptote is still at y equals 0. And so, since I'm going to take all those points, and we said we're going to go to the right 4 and up 2, we can literally just change them to the right 4 up 2. So I'm going to take each one of these points, I'm going to go right 4 and up 2. And there's that 0.43 that we said we should have. And also, because I went up 2, my horizontal asymptote needs to go up 2. And so here is our graph. We're not going to see that y-intercept because it's all the way up at 83, but we know that means it's going to be going up very quickly as we go to the left. All right, example 9. It says graph the function and label the asymptote and the y-intercept. Describe the transformations from y equals 2 to the x. So we need to change this to y equals 2 to the x. So first, that's what I'm going to work on. So this is the same thing as saying negative 1/2 times 1/2, remember, is 2 to the negative 1 to the x. And so this could be negative 1/2 times 2 raised to the negative x. And so we can see that our transformation, the negative in front, means it's going to be a reflection across the x-axis. And then I notice there's negative with the x, so it's going to be and the y-axis. We're going to go across both of them. The 1/2 is a vertical dilation. By 1/2. And then 2 is just my base. So I know we wrote this earlier. I'm going to rewrite it on this one so I can see it. Oops. right, and so we can see if we take each of these, I'm just going to use a table to actually help me with this one. There's a lot going on here. So for my x's, I have that negative x, so I'm going to take my x and divide by -1. So it's just going to change the sign of all of them. And then my y's, I'm going to multiply by that -1/2. My horizontal asymptote. Remember, is it y equals 0? The only thing affecting the y is with the -1/2, so it's not actually going to change. It's still going to be at y equals 0. Alright, so when I go to graph this new one, I still have my horizontal asymptote right there. And then I've got my points here. Uh-oh, I'm going backwards. I didn't catch that. My x's start over at 3 and -1/16. 2, -1/8. 1, -1/4. 0, -1/2. Alright, and so there is our graph. Alright, then example 10 says write an equation for the transformation of the graph f of x equals 4 to the x, then explain the transformation for each graph. So if you notice on A, it says g of x equals f of x minus 3. That just means where there's an x, we're going to put x minus 3. So our g of x is equal to 4 raised to the x minus 3. And so we know that this is going to be a horizontal translation right 3 units. B says h of x equals f of x plus 5. So our h of x is just going to be our 4 to the x and then the plus 5. And this is a vertical translation up 5 units. C has f of -2x. So k of x will equal 4 raised to the -2x. And so we know the negative is a reflection across the the y-axis. And the 2 is a horizontal dilation by 1/2. And then D's got a whole bunch of stuff going on. So D, so we got P of x equals -3 times f of x plus 1. So that's times our 4 raised to the x plus 1 and then minus 2. So I'm going to put that 4 in parentheses there. So we've got a reflection across the x-axis because of the negative in front of the 3. The 3 is a vertical dilation by 3. 4 is just my base. I don't mess with it. The plus 1 in the exponent is a horizontal translation to the left 1 unit. And the minus 2 is a vertical translation down 2 units. All right, and that is the end of lesson 4.